Oh, yeah, good, that was good. It's the first time I clapped my line, so I clap. Welcome to BrumAI number 12. So we've got three really good talks tonight that I'm quite excited about. The first one is from Zain, who's an old BrumAI favourite, come in for a while, part of the furniture. And you might have seen from the BrumAI activity that Zain's been working on a system to recognise Arabic characters, so that it can parse Urdu and similar languages. Awesome. After that, we're going to hear from who's going to talk to us about the Centre for UK Research Assessment and a proposal he's got in mind. And then finally, we've got a talk by Siddhartha, by those two out there. Siddhartha Kastigir from WMG, Warwick. Can somebody help me out?
Warwick Manufacturing Group.
Warwick Manufacturing Group. So they're a research group that work with JLR, amongst other people. He's in the research area to do with self-driving cars. He gave an amazing TED talk, by the way, just a couple of weeks ago on the theme of we should let self-driving cars kill people, which I really urge you to check out. And he's involved in the kind of testing and quality assurance side of things. Working with him and interviewing him today is Joanna, who works at Wealth Wizards, and she's also involved in the safety of AI systems, this time in the area of financial advice. So three really interesting talks, I'm sure you'd agree. What we're going to do is have the first two talks, then we're going to have a bit of a break, probably 10 minutes, have a bit of a chat, a bit more pizza, and then we'll come back for the last talk. How does that sound? Yes, all right. So, to kick us off, Zain, thanks a lot.
Thank you. So, as you may have guessed, the text recognition does use AI. It does use deep learning in particular. And just a quick introduction of deep learning, why it's not that I'm using it because of the hype, although that does help. It's basically, I'm using it because it's the problem I'm trying to solve. It can only be solved by deep learning. It can't be solved by the older machine learning models for how text recognition works classically or historically. So the convolutional and convnets, they're brilliant. One thing I like about them is because you can actually create the feature maps, features of particular, say, letter and it basically iterates over those features again and again, what we call epochs when we're doing the training. Compared to machine learning, where it doesn't do any iteration, it just tries to do it in one go, in one instance. So this is a quick video on how convnets work, a very basic one. Basically, the input, the first layer is the pixel values of the image, and that's sort of training happening. This is breaking down the pixels and inputting them, and the hidden layers are being configured. We don't know what the hidden layers are, but we think that they are basically feature maps, this sort of feature map. So a 9 would correspond with one of them, 4 would correspond with 2 of the feature maps, and that would kind of go down and relate to one label layer. That's what we imagine what would be happening. We don't know actually what's happening in the black box, but hopefully maybe we'll be able to find out with more deep learning research. So the language I'm trying to OCR, it's quite an old language, not too old. The main point here is basically it's written right to left, and it's based in Persian script, which is based on the Arabic script. So we go to so the issues with Urdu text recognition is that I'll come to the next slide, which we'll talk about what's the basic issue. But currently there are a lot of papers out there, and that has been the issue. Not the issue, but that has been the case since good 5-10 years. That a lot of people are writing papers on how to do the OCR. Many of them are basically using machine learning techniques, SVM, sort of how to recognize a character. And the only good solution out there, which does use deep learning, is Google's solution. Some effort is being in Arabic OCR, but the issue with Arabic OCR currently is that someone or organizations are trying to get some volunteers to look at data from, get data from manuscripts of words and label them. So manually labeling images taken off manuscripts. So that's how slow this process is currently. And these are the sort of papers that I came across like even 4 years ago, and I still come across if I do a search. It's great, but some of it's now based on only machine learning and not based on deep learning. Now this is the interesting part here. So Urdu writing, this is what it looks like. The first letter there, that's basically sheen. It represents the sound of sh, sh in English. And when you write it in, say, at the start of a word, you'll take that feature, which is the 3 lines with the 3 dots, and put that there. And then you write the rest of the word. But if you write it in the middle, it depends on what you write at before that letter and after that letter, and how that would be written. And then obviously this is written at the second last and last. So the issue here is that depending on where that letter is in that word, it will have a different shape, and it will have a different location as well in terms of how high it is and how low it is. And that's the sort of crux of the matter, where when you're trying to do that with machine learning techniques, the older ones, it does not work. You need something more robust. And that's where deep learning comes in. So benefits of developing such a system, basically, it's a very difficult problem to tackle because of that. You can't write if statements, or if this, if it's in the beginning, do this one, if it's at the middle, do this, because there are too many rules. The other thing is that it's a great problem to tackle, and also it's something that's related to me, because if there's a problem, say, which is too abstract, then I won't have patience to solve it. But if it's something related to me, then I'll have the patience to go over and have a look at it. And then it's also related to other languages, even non-Arabic scripts, because if it can work for Urdu, the theory would work for any other language, which I'll be presenting in a minute. And it's great for historians if they're doing some research on documents. So the game plan is to recognize a whole word instead of individual letters. And the problem with that is that's approximately 140,000 words. Now, if you remember the second slide where I had the video, and you look at, say, the numbers, you have 0 to 9. That's 10 classes you're trying to classify or distinguish between. And here, that means there are 140,000 classes. Now, that's not something that it can't be done. It can be done, and it has been done by Google. It's just that you need a very large GPU. And the other point here is that for an accuracy of 99.9% or above that, you need what MINST dataset has is 208,000 images in total of 10 different numbers. And that basically divides up to 28,000 pictures. That's in total training, validation, and testing all data included into one. So if I have some sort of understanding of if I need to get a higher accuracy, that's the sort of number I need to generate, sort of thing.
Per word.
So how do I...
So 28,000 multiplied by,
Per word, that's it. So how do I label? I can't ask for volunteers, no one's going to have that much patience. And a software engineer in me was like, this is a tedious problem, and it's repetitive. It's a computer's job. It's not something a human can do. So what I did was, I came up with a way to basically generate the data set, a labeled data set. So what I did was, these are actually the labels. But even to get to this stage, I actually had to take words from 500 books and do a bit of an NLP process. So get rid of all the numbers, or full stops, diacritics, any English words, making sure the spaces are correct, and then from all the different directories where the files were, getting them so that it basically produces one CSV file which has the unique words across all the files. And that kind of gives me this. So that's the input for the next stage, which are just the labels. Unicode, UTF-8. The next thing I do is actually have an algorithm which will put it into different fonts and I have so far about 114 fonts and different font sizes. I'm taking about 12 font sizes right now, and it basically produces images. So for each word, it produces 1,300 pictures. That's basically 114 fonts times by 12 sort of number. I haven't added any filters yet. The next stage is actually to add another for loop, which will actually add filters randomly to different images. So what it looks like, well, this is when I first dreamt this idea that, oh, let me create an algorithm which will label the dataset, create a labeled dataset. I came up, this is what I wrote, which does this. It basically produces the images and it renders them out in a rich text box and takes a screenshot and saves the screenshot and saves the name in the screenshot in the right place. And that's what it does. But this is too slow. In fact, if you to produce images for 100 words, that's 1,300 pictures per word. That's 100,000 images. It takes 3 hours to render all the pictures out. So that was too long. I was like, that's not scalable because I need about 1 billion pictures, right? So I actually came up with another algorithm which basically reduced the time, basically by not rendering it out on the screen, but basically producing it within a graphics box, and it saves the graphics box and makes sure the picture is small enough, because you can't have a too big image, because what the neural network will take is the pixels. So if you have a smaller image, it's better. So I have produced a smaller image. So does anyone take a guess how long this algorithm takes now to execute 100,000 images to render out? Any guesses?
2 hours.
Any other guesses? 20 minutes? Okay, it takes 6 minutes.
Yes.
So
6 minutes.
even that, I think it can be sped up. But this is now set up so that it can actually be. It's only one single thread. So basically, the next idea is that if I need to scale up, multiple threading. Benefit of generating a dataset, basically, it's pretty obvious. You have as big of a dataset as you want, and you can add whatever filters you want. You can create whatever filters you want and then add them to all the images. And how you add them, you can have them so that when the filters are being generated, they're also generated randomly. So there's a random effect. So every filter is different, and then add those filters to the dataset. So for training the model, I basically used Keras. Keras, I found it's ridiculously more beautiful than using TensorFlow. The documentation is so nice, and basically it's much easier to configure, and it's much easier to quickly configure. And I was like, that it basically lets me work with it some faster. Also, it's just that it's one less thing to worry about. If I have to work on TensorFlow, then it's a lot of things I have to configure. Whereas Keras, it takes care of all those things. Colab was my GPU. Basically, what I did was I did my initial training on the laptop. It ramped up the temperature to 60 degrees on the laptop, and after 10 minutes, the laptop switched off because it just couldn't handle it. So I was like, that's not feasible at all. So I need to basically find an alternative. So what I did was like, I've heard of Google Colab. I've seen it, but I haven't used it properly. So I'll try it, give it a go. And that seemed to be the answer. Very quickly, actually, basically crossed their limits, you can say. But whatever the free limits were, 11 gig and 12 hours of usage. I think it's at a time because I've done it like more than 12 hours now. So this is the initial good results. Now I'm trying to classify 140,000 words. So that's 140,000 classes. So obviously that's going to take too much time to train. I thought I'll start with something smaller. So I didn't start with something which is say 1,000 or 200 or even 100. I went down to the absolute minimum, just classifying 2 words. So it was a binary classification. And because the data was still the same, 1,000 pictures, 1,300 pictures for each word, it basically, when it classified, the way I tested it, so obviously, I'm not saying the test of how well it performed in accuracy, that's not what I tested for, that's their own numbers. What I did was I basically took a new picture and I handwrote the word and took a picture with the phone, and put it in, and it basically came out exactly what I was hoping. So the thing was, I was just blown away that's not, I wasn't expecting that at all. I was expecting it to, because it's trained on a computer-generated data set, it should only be able to recognize computer-generated. It should have a issue, recognizing a handwritten image, but it didn't. The next, obviously, part is to scale up. So scaled up to just outside binary, I classified 3 words. It worked well. Then I scaled up to 10 words. It worked really well. Then I scaled up to 20 words, and it still worked really well. I think this is 20 words, and it's still working really well. This is an image from an old periodical, and that's classifying really well. That's handwritten, and that's handwritten as well, and that's classifying exactly right. But there were a few where it was failing in 20 words, and the architecture was fairly light. So it wasn't basically, what I mean by architecture is that it wasn't heavy in terms of layers and filters and the amount of the hidden layers, that sort of thing. It was very light, but it was still performing really well. So the next thing was to basically scale up to 100 words, and it takes a long time because first you have to upload it to Google Colab. So once you upload to Google Colab, it takes a long time to extract first. Once it's there, then it takes a long time to train. But that architecture, it failed miserably. Because if you think about it, normally what happens is when you scale up in terms of data or in terms of how the architecture will behave, so you have more nodes, more hidden layers, or more nodes within the hidden layers. But here I'm actually scaling up in all of pretty much this classes of what's it's distinguishing between. So that's it's a different kind of scaling up. Then I basically got a different, I think it's probably in the next slide. So the scale problem. I actually thought I didn't have a scale problem because the dataset generation algorithm was basically written so that it will actually, if I need to create more words, or create more images, it'll be fine, it'll behave, and the time would be okay. But it just turns out that there's a problem with 100 classes. So, when I actually have a sophisticated architecture, so actually adding more hidden layers, then and adding dropouts and stuff, what happens is it doesn't actually compile on Google Colab because of the 11 gigabytes of RAM limit. So, and that basically happened when I basically compiled the whole connet, and just when I started that .classify.fit, that it failed at that point. That it's basically overran the RAM because of fitting the whole thing, and it just can't do it. So I was like, oh, that's not good. So that's basically the scale problem right now. And I think it's not. It's basically an issue in terms of I can go out and pay for the GPUs, and I think that's what I'm going to talk about in the next slide. So basically, is to
where you lot come in.
So basically, to actually play with a sophisticated architecture, which I would know that it will work. Once I'm sure, so I'll try with slightly less layers. Once I know that this will work, then I can actually put it onto Google Colab and see how long it takes to classify 100 words. And if I'm happy with that, because I know when I classify 2 words, or anything between 2 to 20, it does classify to such an extent that it actually recognizes handwritten, which is beyond it was beyond my expectations. So I know that's basically its benchmark. With 100 words, that should be its benchmark, basically. And that's the idea. Then I'm thinking of paying for GPUs, GCP or Floyd Hub sort of thing, and generate data with filters. That's not done yet. That's basically because the data is too clean. I'm not sure if you still saw the numbers of accuracy, it was 99% for some of them, and that's because the data is too easy to learn because it's generated by a computer. So I thought actually that I fooled the AI because I just gave it the data which I created, and it's not something I labeled, but now it actually knows that this is too easy, and it learned it really quickly. So I need to actually add labels and noise and stuff so that it actually has slight difficulty and classifies only the right word basically, and scale up to 140,000 words and get 99% accuracy. I think it's possible because of the it suddenly is done with Google, because what they do is they classify, obviously they not only dogs and cats, they will classify different breeds of dogs. So they have this tree structure of classifying, or pretty much like a decision tree, where each node is basically trained. So they have these classes where each class is subclass of another. So that's I know it can be done. It's just that it has to be basically tested. So that's basically next step. That's it. Any questions?
Did you try randomizing the words each time to see if it behaves differently based on the set of words? So say you tried with 50 words, then every time you try to predict, randomize the words based on what you trained it.
Yeah. So it's.
So does it have different results, or?
It basically what I did was every time I tested on a few different things. One is I tested on a word which is generated by computer. So by what I mean by that is that it's, say, you type it up, so you type up Urdu book or something, and it's scanned to the highest quality, and that is fed into the network. So that's basically generated typed up by computer, generated and printed, and then it's recognizing that. That's one test. And the other test is, can it do slightly difficult, so the older periodicals 100 years ago, because they used to actually write with a very good font, because there was no typewriters, well there were, but it was difficult. So they have to write it, and I tested on that. And the most difficult test is basically handwritten. Can it recognize handwritten if its image is large enough and the image is good enough?
I'm asking whether to see if there is specific words that make it harder to distinguish rather than other words.
When you scale up to 100, actually, it's almost all of them will basically be hard to learn, because it's trying to distinguish and it finds it really hard. And the thing is, that's why I talked about the initial how concatenates work, because of within the black box, you have the hidden layers. They will create a feature map. Now they will obviously, how many nodes you have, they will create one feature of this is one sort of image what you will find in this data set. And it will try to go to that. So what I need is, I need to basically find the unique number of different images or different features I can find in Urdu writing. If I can just say, even guess, say it's this much, and put that in, I might actually have better success than just putting in a random, say, 64 layers. So that's the sort of thing that, what's next?
I can't quite understand why did you decide to do words. I mean, I got that each letter can be written in a few different ways, but surely there's a finite number of ways. So if there's 5 ways to write a letter, and there's, 30 letters, there's 150 classes instead of 140,000.
So there are, basically what happens is, so if I go back to, sorry about that. So here, it's basically, these are the three different words.
Sure.
And what I'm trying to show here is that how this letter, one of 36 Urdu letters, appears in 3 different words.
Yeah.
But
shouldn't there's a finite number, so you can have multiple classes corresponding to a single letter?
Yeah, so what happens is, normally in English, the way OCR would work is, you have 26 letters, and you double that, so 52 that's what you have normally, 52 different images you need to classify in any given text. But what happens in Urdu is joined up, and it's different position where is it in that image. And that's the trouble, because either you could try and do something slightly more sophisticated, where I think that could be an issue where you try to do the shape of that, but still it's complicated.
But, I mean, you can basically have several different classes corresponding to a single letter. Like,
Yeah.
So, I mean, there's what, like 5 ways you write to it?
No, it's not. It's not 5 ways.
Does it appear differently in every single word?
Almost. That's the thing. Almost. It's not every.
language.
It's not every single way, but it's almost like that. But what could happen is, if it's, say here, for example, this is the first letter is A. The second is that one. The third is actually A again. Now, because of how it's written after this letter, it's joined up this way. But when it's written before it, it's joined up in a different way. And when you have such a combination, and then you have that for 140,000 words, that's a lot of different ways it can be written. That's why it's either easier to do this, or either try to find the other way is basically to say, I know that these 2 letters appear together quite often, so I will classify these 2 letters together, and that actually may reduce the number of classes. That's the way of reducing it. Yeah.
So this language is sort of it's halfway between an actual alphabet and a pictobet. It's a sort of hybrid. You're saying?
It could be. It's there are certain languages which are like this, and there are other which are even difficult to OCR. Japanese and Chinese are really
They're complete pictobets.
Yeah, that's it. But the thing is that it does have, obviously, it's very, when you're young and when you start to learn to read it, it makes sense. A human can read it, and it's no trouble whatsoever. But certain things are difficult for a computer, and that seems to be one of the things. That's why the text recognition for Urdu or Arabic is not there.
Does the shape of the letter only depend on the letter before and the letter afterwards, or other letters in the word?
No, so only basically the letter before and after.
Okay.
And so here, if you look, this is the same letter, and it's the same shape, but it's just joined up with another one of the same kind. Now, the way I know that is that there are 3 dots, and it's joined up. So this is how I know that this is the same letter. But this is what happens, that the second last letter is exactly the same letter, but it's only, we know that there are 3 dots there. So this is the thing, if you try to classify that sort of shape, this is the difficulty. You will run into so many different things you need to classify. Yeah.
Have you thought of codifying the as a rule as to how the letter should look when it's after a particular letter? So I presume that you have 36 letters,
Yeah.
and every letter could have 36 letters on the right or 36 letters on the left. So there still is a finite number of combinations. Have you thought of codifying that the whole pictobit?
No, I'm not, but what, say there are combinations of, but I'm not classifying only one.
Yeah.
I'm classifying 140,000. Even if we say reduce it down to 100,000.
No, what I meant was just building upon the earlier point of
Yeah.
classifying individual letters rather than words. So the argument you made was the way the letter is changes based on what is after and before.
Yeah.
So I'm saying, could you codify that metamorphosis of that letter, because the number of letters after and before is always finite, so it would be a finite number of combinations.
Yeah. I could think about it. Yeah.
Can you treat this as a recurrent network? Because you need to find a way to scan from left to right. Is it left to right?
Right to left.
Okay, right to left. And you basically say that it depends on how you draw the letter and how you put it, depending on what's there. Now, probably you can't have just a line. You need to have a box. But think about the process of transliterating the Urdu into Latin language.
Yeah.
So you could think of maybe some way of marking a window of X number of pixels wide into a sequence of Latin characters.
Yeah.
Because I think to have a network that outputs 100,000 classes, no way. Yeah, you need to have this hierarchical structure. And even so, I think you need some amazing resources for that.
The biggest issue seems to be the resources.
Yeah.
Great, thanks a lot for your time, Zain. That was a really awesome talk. Thanks. So we can chat to Zain about his crazy